who are listening to this now, you missed a lot. Here you go. Make sure you write this down. You can skip all that stuff. That was just interesting, but forget it. Okay. There you go. Then we did this one. The idea is you're using an identity to reduce the power from a squared to a first degree so that you can then integrate. You do a mental use of, and that's where we're at. Now they're trying the next one. Okay, so here we go, back up to speed. You're probably then saying, why didn't you make it that fast? Yeah, we could have done that. I should have just watched the videos from now on. Watch it in half the time. Yeah, just fast forward through my blah, blah, blah to start. So, if you pull out a half and integrate cosine of 2x, you can see that it's almost identical. The only difference is the sign. People want to say, wait a second, so this is sine and cosine, shouldn't this be cosine? No, they're all cosine. Both of them use cosine. Okay? So 1/2 x plus 1/4 sine of 2x plus c. You follow it? Okay. Now, there are a couple free little wrinkles here, but they're not a big deal. Most people do fine with these. So just so you're prepared when they throw them at you. I said that the double angle identity is u to 2u, but really it's just the identity is twice whatever was there before. Okay? So when you go to sine of 4x and you make this identity, remember that it's twice whatever was there before, so now it'll be 8x. Okay? So if I go to make the substitution, it's 1/2, is this the plus or the minus? Is sine plus or minus? It's minus 1/2 cosine, and the double angle identity is double what was there, so it's 8x. After that, it's almost all the same work. The only difference is the U balancer will be related to 8 rather than 2. So you'll have 1/2 dx minus 1/2 cosine 8x. The first term, 1/2 x, is easy enough. So what is the u now? 8x, so du is 8 dx, so we'll need 8 to balance. So our end result then is more like 1/2 x minus 1/16 sine of 8x plus 6. Cool? You don't. You can show less work. I'm trying to find a kind of a happy medium between, making myself clear but not making it all day kind of problem. So yeah, you can show that. Okay. So this one, sometimes it's even powers a trig, and surely 2 is a nice even power, but sometimes they go bigger. So cosine of the 4. What do you think we could do? I hear a lot of mumbling. I'm actually waiting for you to say something. Don't write that.
Give up.
No, give up is never the option. Come on, give me. You got a 4th degree. What should you do?
Cosine squared.
Cosine squared, cosine squared. Okay, great. Cosine squared, cosine squared. That's starting to look more like stuff we have stuff for. So now what? Let's use those identities. 1/2 plus 1/2 cosine of 2x times 1/2 plus 1/2 cosine of 2x. Foiled out is 1/4 plus 1/4 plus 1/4, so 1/2 cosine of 2x plus 1/2 cosine times 1/2 cosine. 1/4 cosine squared 2x. Okay. The first one I think I can integrate now. 1/4 dx should be fine. The next one I think I can integrate. 1/2 cosine of 2x dx should be fine. However, 1/4. Uh-oh. Cosine squared. What should I do? Do it again, yeah. So if I substitute for an identity for that, I'll have 1/2 plus 1/2 cosine 4x dx. So I start working it out, and I have 1/4 x plus that second integral. You do your u du thing, and what do you get? 1/4 sine of 2x plus maybe a new split of 1/8 dx plus 1/8 integral of cosine 4x, and you might be able to do this in less steps, and that's fine. I think I finally get 1/4 x plus 1/4 sine of 2x plus 1/8 x plus, and then how does that last one work out? 1/32. You'd have a u of 4x, a du of 4 dx, a balancing 1/4, and you'd have a 1/32 sine of 4x plus. That's not ridiculous. I don't think they go worse than that. Okay, but I don't promise you. Okay, last, an application error. I think yours says sine of x. I prefer it to be sine of 2x. Could you change that to sine of 2x? And try that on your own. Let's see if you're getting the idea. And it's good to practice the skill that I require in a test, that you can put two ideas together. It should be first quadrant region. There are a lot of first quadrant regions enclosed. I mean the first quadrant region. You understand what I'm saying? Yes. Okay. Disk or washer? Pi over 2, it should be just like that. I just said it. So, what'd you get for an answer? Pi squared over 4. Agree. What you got? Are you good?
Wait, why does it stop at 5 or 2 instead of like 2?
Why is it what?
Stop at 5.
The way it read, first quadrant region, well, that's actually a lot of first quadrant regions. I wanted you to just show me the first. As far as y pi over 2, the period, because I changed it to 2x, the period is changed to pi. Okay? Questions? Okay, cool. Do you still need your test for correction purposes? Some are yes and some are no. I'll come to you and just tell me yes or no. Here's some homework specs for your enjoyment. And they said if you don't need your test back, let me know. Grace?
No, thank you.
Okay. Sammy? You think so, though? You think so, you're done? Oh, okay. Ellen? You sure? Yeah, no problem. If you're not sure, then feel free to just take it. Sebastian?
Yeah, yes, please.
All right. Lauren? Angie?
No.
You good? Carla? Macy? Okay. Sean? Robert? Nate?
No, thank you.
Judy? Clinton?
No,
James?
thanks.
Okay. Veronica? Liz?
I don't remember.
Kyle? Liz? Melissa? Kyle? Kyle, we went for... You went over this Melissa, your turn. This is good. This is correct. Yeah, I think you're how. He already
Depends on when you're done. Considering less than
yeah, so we know if you can win there, it'll be less.
this one, what do you mean by
I needed to see somehow that was JDT equals yeah, the area is basically twice as fast as the rate of change. The area's rate of change is twice the rate of change. So this is what's the derivative T. The only way you get here is if you plug that to the RDT. It's written and maybe you just need it when you get
And so we can correct this.
this and this on that page, and that, and that. Okay, well, first, basically the first and last problem.
Kyle agreed to anything you asked.
Yes, exactly.
Why do you think I asked him?
It is, so you're trying to get, there's actually, there might be one on tonight's homework too, so this is good. Did I actually, let me finish giving people their list, sorry, then, oh, never mind, I should ask them. Okay, so. This is what you saw last year, because I think in terms of where we go, the point is trying to, your goal is to try and get it to base form, which is to say you can get it to 1 plus CN squared. I said it was 3 comma 1. And so that really is also a whole.
Okay, wait, Quentin, I already had.
So that actually will work out way more. If this was X squared, then this point is going to be then you would have X squared. So check this out. You want to start by making this you want to make this so if you actually okay, so now your idea is to identify here if the squared
Plus is not.
is 3 that implies oh, super. Thank you. How so that means XPX, if I go to some place of X, it would be
This volume is on. What is the change rate of change?
So if you substitute that point in place of X, and you already changed it,
Oh, okay.
then you have 0
Equals 0 plus.
1 over 10.
I got. Quentin. Sort of.
Yes, ma'am.
So is this I'm not okay, where to go?
Yeah, because, so the idea is that the force or the word, instead of putting some of these on the sheet, cross section.
So what would happen to this one? One of those would get okay, so okay. And then you have, oh, you have 1 minus 2x squared.
Then I is minus R
Side How does this impact?
So that's what you're getting out of cylinders. And then the distance is going to be.
Oh, so before minus.
Oh,
But then you still have this one half.
so sometimes, in almost all times,
Then you still have this one half.
that's literally all right.
CSS is basically just a styling language. It's not actually.
Okay.
It's basically edits. But basically. And you can use CSS.
I don't know what I do.
All right, once the majority are ready to move on, we'll go to questions. Yes, sir.
Just wanted your sandwich there.
Yep. No,
Okay,
just
so
the
just
functions
like
themselves, yeah. So I usually start with stating the duty, but the function within the function is not the
In this case,
It's, oh, so, okay.
Okay, so
Yeah.
let's
I agree with that. if they're all points are the same, then surely the approach is going to be the same. So the rate- This is the question, and that's what you're trying to squeeze. You see that once you put the functions, these limits will be able to, these other and that's what's going to achieve a squeeze. This will be, this integral will be given on. You see where we're headed, or shall I?
I mean, so.
No, just, no, so the derivative and the approach is only for thinking for L'Hopital. This one's not about the rate of approach, it's just. So what you're gonna do is
You didn't answer the question. You got a question.
F is x squared equals 2. Is x equal to 0, the other function is. Now I know that is x goes to 0 here. Oh, now I see what you're saying. That's, so now that's what you're saying.
Why am I so lazy?
Sorry. Well, see, that's, this, I mean, this is
You didn't break like, f of x is supposed to be 5 plus.
so you could say, I know that sine of x over x, because sine of x so many times is 1, so this is -2. But really, I mean, it is a, you determine to put either of those. This is x goes to 0.
You got it right.
Okay.
Yeah, all right, awesome. Thank you.
If you get your, if you have your test still, your working with corrections right here, please, or hand it to me when I'm walking around. It's fine. And thank you. Dude, what happened? Oh, soccer? I didn't even know. What happened? Did you totally mess up the other guys? He walked through and almost did it.
Oh, yeah.
That's all right. Let's see. Give you another minute or move on to homework questions? Move on. Move on. Did you get a chance to look at this question on 80, the homework pharmaceutical problem? Okay. Some people did turn in set 80. Some,
Turn 80 in any morning?
No, he wrote it.
I wasn't sure. I wrote it on the board, but then everybody left, and I wasn't sure if it was clear if it was due or not. So that said, I had conferences, so I haven't graded 80 or 81. If you want it back, then you can go back to the basket and get it. If it's fine, that's fine. All right? However, I did want to talk about this problem because it's good stuff, both in terms of math and in terms of just life. So here we go. So do you remember this problem? Am I all by myself up here?
No, I do.
Oh, okay.
I just, you can pass me.
Okay, so, all right, so they have a $100 million startup cost, okay? You with me? That's a lot. And yet, that's what research and development costs on pharmaceuticals. So what if only 500,000 people have this disease? Is it profitable for you to investigate curing this disease? No. Probably not. I don't know. So there's a ton of ethics to this. That's why I like this question, because there's a lot of ethics to talk about in here. So at any rate, there's this huge cost to develop and research a drug that takes 10 to 20 years to get to market. So they finally get the pill, and the cost depends on two things: the $100 million to make the pill, and then that's for the recipe. And then it's 40 cents in raw materials for every pill to be made. So the total cost then is 100 million plus 0.4 times however many pills you make, all right? So let's talk cost per pill. What if I make 0 pills? What's the cost per pill? 100 million, okay? If I make 1 pill, what's the cost per pill?
100 million plus
$100 million in
40 cents.
40 cents, okay? What if I make 2 pills? What's the cost per pill?
100 million.
$50 million in 40 cents, okay? So I just reduced the cost per pill from 100 million to a really cheap 50 million, yeah? What if I made 10 pills? And what's the cost per pill? $10 million and 40 cents, okay? So you can see that it's what's called the economy of scale. If you're going to have that much startup cost, then you better be ready to make a lot, okay? Because if you only make one, then the burden of that whole 100 million falls on that one pill. But if you make billions, then the $100 million is distributed among a billion pills, and that startup cost is not so bad. So again, on a big scale. That's why you would first determine the market for this before you put in $100 million and even go there. So the cost per pill then generally would be, I'll call it U for unit cost. You could often see that as C-bar, but the total cost divided by how many pills. If I take the total cost and divide it by how many pills, then I would get something like $100 million divided amongst the n pills plus 40 cents for every pill. Yeah? Okay. How many sales does the company, after how many sales does the company break even? How do you go about this? Break even when what equals what?
Revenue equals cost.
When revenue equals cost or expenses. Say what
Is
question?
it plus 0.4 or plus 0.4n?
Plus 0.4, because if I took this and put all of it over n, I could put each individually over n. So I'm basically saying take the cost function, put each over n. Okay, so revenue equals cost or expenses. What's the equation for revenue based on how many pills you sell? It says up here, $75 per pill times the number of pills you sell. The cost you have from part A or B? Do I want the total cost or the unit cost? Total cost. I want to know when these are equal. Okay, so if I subtract 0.4 over, I get something like 74.6 n equals 100 million. Divide that by 74.6, which I would imagine is like dividing by 3/4, 400 thirds, 400, it's about 77.5 million, maybe? Okay, I'm taking a guess at about 7.5 million.
What kind of pill costs $75 a piece?
Oh my word, that's cheap.
That's cheap.
There are pills that cost in excess, I mean, did you hear about, there's a company in Canada. Did you hear about this last year? This is the ethics component to me. They buy companies that are undervaluing their pill. And they buy the company and jack up the price by 500%. Because this is what the executive honestly says. What are they going to do? They need it to live. Well, you got a point there, but are you a total bastard who's determined who's bound for hell? Yes, you are. I mean, can you believe that somebody would? Capitalism is great, but come on, I mean, geez, please. They honestly jacked up the price to the point where only the richest person could afford it, and people died as a consequence of it. At any rate, so yes, there are pills that cost in excess of thousands of dollars that people need to live, and people died because they can't afford it. This whole thing was played out with the AIDS cure. I mean, in Africa, they can't afford $100 per pill, $500 per pill. So, at what point is it ethical to charge that? Is the company there to make friends? No. And do they lose employees if they don't make a profit? Yeah. So they go out of business. Yeah. But I don't know. What do you think? Once you make the money from the R&D and can you reduce the price a little, I mean, come on, you know. I don't know. Like I said, Quentin, you're a good prophet, so you're probably saying it's 52. I'm a teacher for a reason. I'm a terrible business person. I'm a softie.
I mean,
Okay.
if you're not going to make money off of it, why make the pill at all? For some
Because you're in the business to save lives.
Every
You're
business
saving lives.
the business of making money. The point being, they're already making a profit, they just wanted more profit.
Oh, yeah, I agree with that. As long as they're making a profit, they shouldn't be going crazy. Yes, and
The
so,
problem with like the robber bases is,
yeah,
they
stick it
throw
to
everyone else out just to reduce the price.
and I mean, there's super rules here about reverse engineering the pill. An American company can't take this to their lab, reverse engineer it, and make it themselves an engineered brand until so many years pass. But there's nothing, I mean, China does it all the time. Everybody, and the black market does it all the time. They say, hey, you made this AIDS drug, you put in $100 million to research it, now I'm gonna reverse engineer it for, $5 million. Anyway, I think anywho, sorry, look,
Was that for recording?
oh yeah, sorry. Feel free to send this home and say, this way it's communist. Sorry, like I say, I'm a terrible business person. I just think. All right, so anyway, back to the math, which actually is something I'm supposed to be talking about. We're educated people. Isn't it fun to discuss things? Maybe not. Okay, so as the number of it goes without bound, what happens when you take the number of pills to infinity on the cost per pill? What does the unit cost or the cost per pill approach? Yeah, it starts to approach 40 cents. What happens to the 100 million startup cost? It goes pretty much to nothing because it's being distributed among so many pills that it's like 1 cent now per pill and a tenth of a cent per pill. And it starts to be just about the raw material, which always is going to be there, regardless of how many pills. You with me? Okay. So that was that. I just want to make sure I did a good job explaining that because I felt like that was rational functions application problem. All this vertical horizontal asymptote that you talk about, these rational functions you do, there's a point to it. Okay, they have real life meaning. Obviously, we're going to be dealing with the whole 4 quadrant element to it, but the first quadrant element is there, and there's something to be done. Okay. What else do we have on 80, 81, 82?
Number 4 on 80.
80, number 80, number 4.
22 on 81.
22 on 81. I'm going to do these in order.
82.
I'll take either one. 81, 22, did you say?
Yeah.
Okay, 84, 81, 22.
Number 2 on
2 on 80.
80. 82 number 2.
82, 2.
82 1.
82, 1. Okay, are we cool? If you have something else, let me know. 84, I just want to make sure that I heard you right. I need to do 84, yes? Is that you, Anelka?
Yes.
Okay, 80 number 4. To me, I had the most problem or errors. Actually, the calculus was pretty sloppy too, but did you get, I assume you started with the volume is 1/3 or pi thirds r squared h, which is pi thirds x squared y, and the x only relationship, the one I used is the Pythagorean theorem, x squared plus y squared equals, that squared is 16 times 48, so y is the root of 48 minus x squared. Okay, so if that goes in there, then I get pi over 3x squared root 48 minus x squared. All right, so then the calculus, unfortunately the critical numbers and the derivative gets a little sloppy, but with some slow methodical cleanup it should go okay. So first stays the same. Derivative of the root is 1/2. 48 minus x squared to the negative 1/2 times the inside derivative negative 2x plus second stays the same. Derivative of the first is 2 pi over 3x. All right.
Actually, that's higher than 3 hours.
Oh, that's probably a good call. So let's do that. All right. So when I do that, I drop a 2, and I have negative x cubed plus x or x over root 48 minus x squared plus x 2x root 48 minus x squared. Okay, so common denominator then is root 48 minus x squared. So I get something like negative x cubed plus 2x times 48 minus x squared. It'll start to get better now. Pi over 3. I get negative 3x squared plus 96x over root 48 minus x squared. At the end then, pi over 3, I can take a negative 3x out, leaving me with x minus 32. This is a cube, sorry. X squared minus 32 over 48 minus x squared. Finally then, I get critical numbers at x equals 0, which is not a very good cone. That's actually a minimum value. For the square root of 48, which is also not a very good cone because that's the slant height, that's no cone. And the top, positive root 32, so 4 root 2. That you'll see with the sign test, if you chose to, it is a maximum, it goes positive. Okay, so that gets you rolling. The dimensions are x is 4 root 2. The y is 48 minus 4 root 2 squared. So that's 48 minus 32 square rooted, that's 4. There's the dimensions, you can find the volume. Does that get you one?
Yes.
Okay, cool. 8122. Does somebody need 8122? All right. 8122. Oh, this one I thought was a really good one, and it would be a part C of a AP question. It requires that kind of depth of knowledge or thinking. And somebody in 7th hour yesterday said, I just don't understand how you thought to get there. I understand what you did, but why did you do it? Why did you think that way? So, for what values of k would this have 2 tangent lines parallel to the x-axis? If you are not sure where this is going, just get into it and do something, okay? You're trying to get to right answer land, and the only thing that won't work is staying right here, okay? If you go somewhere, you got a chance. So just start into it. If it has 2 parallel tangents, 2 tangents parallel to the x-axis, what does that imply? Slope is 0 twice, okay? And what gives you slope? Derivative. Derivative is 0 twice. Okay, well, at that point I'm thinking, oh, okay, whatever. I guess I'll need the derivative. 4x squared plus 4kx plus 5 needs to equal 0 twice. Now what? Quadratic. Okay, so it's a quadratic, so I guess I could solve it that way. Let's solve it. Negative b is negative 4k plus or minus b squared is 16k squared minus 4ac over 2a needs to equal 0 twice. All right, now here's where we go back to a topic you talked about in algebra 2. And what kind of scenarios can I get at this? You can get 2 real if the square root is positive. Can you get 1 real? You can, and what's the case? If the inside is 0, because then plus or minus wouldn't do 2 things, it would do 1. So that would be 1 solution. In what case could you get no reals? Negative in the root. So I think you'll agree that at this point I don't care about this stuff. Who cares? It's about 16k squared minus 80 being greater than 0 to get 2 real solutions. And so that was my thought process. And then you go into it, and k squared has to be greater than 50 or 5. 5, right?
Yes.
So k must be greater than. Talk to me about solutions. This is kind of a dangerous inequality. K is Greater than root 5 or, and I don't know if I have that other solution in my, did anybody look at my key? Did I have that, I had the negative one?
It was like in a weird place when it was there.
Oh, okay. Oh, yes, all right, so that's another way of writing this disjunction is to say the distance from 0 has to be beyond. Yeah, that's, you'll see that also used for disjunction. Okay? All right, 80 number 2. Is 82? If you have questions, I'll be happy to do whatever,
Just a
but.
limited information, I think that would.
Sure. Okay. Have a good day. Can I get 80 and 81 today, please? And have a great show.
Thank you.
Good luck. Do see the show this weekend. Yeah, shut up for a second.
Yeah, that was just me. Awesome.
If you're in the show, triple extra credit? No, don't give them extra.
Please give me extra.
Don't give them extra. Don't do it. Rectangular basis, 4 meters high. All right, so where'd you draw your origin? Quite a few words. Did you draw
At the bottom of the box.
Okay. 4, 5, 6, get 2.
You know what? I don't know if that's close to this, but this one's just gonna be like I don't know if you said what I did. So, oh yeah, you stick it to or something like that. I don't know. I don't know the real quote, so I feel like it's better.
Okay, thank you. Now, if I didn't get your test, make sure I get it back, please.
Is good Catholics have, you know,
I just had a question on number 2. Why did the immigrants
Except we do nothing, we use computer.
You're Did I have that on my list?
Yeah.
Oh.
X, but it's in
Yeah, no, I'm totally wrong. It should be 0 to 2.
Okay, that's what I did.
That's, yeah.
That was my question, yeah.
Sorry, I made a mistake in that
So 82 is not.
82 is not due. 80 and 81 are due.
Oh.
And then you get her installed.
Could you explain this?
There's like 4 or 5 for.
So I get the first one. Yeah, by 9.
So 82, that is not going to be good. Okay, so if you got how many? 4 minus X. If you then broke up the other six, top and bottom, just put it on 4 daughters, 2, which is.
Oh, gotcha.
Turn 81 yet?
You will today.
Just ask. I can see like the end of 22. But okay, sure.
I use the
Sure. All right. I'm gonna drink water.
No, for the computers and stuff.
Oh.
You too, Macy.
Like, no big deal in 4. How would that work? They're already playing less than 40. I'm like, what? They can get there for like, they're only like 40. I don't know. Yeah, they look pretty old. No, I'm kind of glad I didn't too. I'm glad I didn't. Yeah, I would like it. This is the same amount of work. It's just a different. I can always. Yeah. Of course, Sarah didn't have fun with Spanish. She came from smart and she got food and all that stuff. Like, I'm so glad. Because she has 8. No, that's retail. No, she's an 8. Oh, yeah. Yeah. Like, I freaking like Jamie Terry was last year. Freaking how? Our grades are all. Our entire. Way too extra. either. How would you call it? Wait, what college are you? WashU. Oh my god, my dad wants me to go there. Isn't it? They have this division 3. My dad wants to go through basketball. What? Go through basketball. I will. How you want? Yeah. I don't know. I feel like stack it and not just kind of I was like, Cammy. Okay, no, I tried it, but I wasn't right. It was like the test. It was like exactly you should ask to know. I know. I'll do it. Yes, I'll take 8. I know. Just give me the sheet then. Yeah. Anybody fun? Wait, are you going?
How you get here?
Yeah, I'm good.
Hello.
Me as well.
All right, I will mark you as checking and thank you very much. Thank you for helping.
Uh-huh. Uh-huh.
All right. Wasn't very. Oh man, I still haven't stopped this.